Okay, for this next part of 5.2, we're going to talk about factoring difference of cubes and sum of cubes. And we're going to do them together so you can see the similarities between them. And then if you need more examples, there will be a second video going over the last examples for this. With that, let's look at difference of cubes first. So this is when we are going to start with two terms, just like difference of squares, but now instead of having perfect squares, we're going to have perfect cubes. Knowing some perfect cube numbers might be useful, and again, this is on the calculator part of the test, so if you need help writing these down, you can use your calculator to make a list so you have a quick reference. For our perfect squares up there, you would need numbers that are raised to the power of 2. For perfect cubes, we need numbers raised to the power of 3. So 1 raised to the power of 3 is 1. 2 raised to the power of 3 is going to be 8. 3 raised to the power of 3 is 27. 4 raised to the power of 3 is going to be 64. And then 5 raised to the power of 3 is 125. And again, we might have numbers bigger than this because we are working with a calculator part of the test. But you can make your list longer if you need to. For now, that's all we would need. Okay. The other option that we are going to talk about in this one is a sum of two cubes. So a sum of two cubes we are going to be adding, and we are going to have perfect cubed numbers. So like 1, 8, 27, those are perfect cubes. When we factor these, when you have a difference of cubes, you are going to find your A and your B value, and those are going to be set up in your first parenthesis where you are subtracting. In your sum of cubes, we're going to again find our A and our B value, and your first parenthesis is going to be A plus B. So difference we subtract in our first one, sum we add in our first one. Then the remaining amount, and you do need to have this memorized, we are going to be adding, and you're going to take your A value squared plus A times B plus your B value squared. And you'll notice those variables are the same setup in our sum of cubes. We have A squared, AB, and B squared. The only thing that is different between them is if we are adding or subtracting that AB value. The way that I remind myself is whenever we have two perfect cubes, when we factor it, we should only have one subtraction sign in our parentheses. So if we look, this first one, our first subtraction sign is in between A and B. And then down here, our subtraction sign is in our second set of parentheses in front of our AB value. So only subtracting once. All right, with that said, we're going to go over our A example in both of these. So the first thing we need to do is figure out what our A and our B values are. And just like we did with our perfect squares, we are going to find that by doing the cubed root of 8x cubed, and then the cubed root of 1. And if these are perfect cubes, then we are able to factor it. So when you do the cubed root, you are going to do your factor tree, and then you are going to look for groups of 3. If you have some bigger numbers, that might take a while. So you are able, again, this is on the calculator part, you are able to use your calculator. So let me pull mine up really quick. When you are using your calculator to get the cubed root, you are going to hit the math button, which is under alpha. So that one highlighted in red over there. And then if you look at this list, if you look at number 4, that has 3 with a square root sign. That means cubed root. If you look at number 5, this one has an X and then the square root sign. Number 5, you can put in whatever index there. So if you needed to take the 7th root, you would use number 5, and it would allow you to put a 7 there. But for now, we only need the cubed root, so we'll hit math, and then number 4 for the cubed root. And we can do the cubed root of 8. That equals 2. So the cubed root of 8x cubed would be 2x. And then the cubed root of 1 is just going to be 1. So if you need help from the calculator, you hit math and then number 4. And you can take the cubed root of any number. Okay, so then back to this. Now, because we know we have two cubes and we are subtracting, we're going to factor using our difference of cubes. The first set of parentheses is A minus B. So our A value here is 2x and B is 1. So we're going to factor that into 2x minus 1. So difference starts with a difference or subtracting. Then, and you probably want to have this memorized, it's going to help an awful lot, we are going to have our a value squared plus a times b plus our b value squared. When you square it, you need to make sure you square the whole thing. So that means you're squaring 2 and you're squaring the x. So when we square it 2x, that's going to come out to 4x squared. Then when we find AB, we're multiplying 2x times 1. In this case, that still equals 2x. And then we need to take our b value squared. In this one, b is 1, so when we square that, it's still going to equal 1. That is your factored answer. You are not going to be able to factor this one up any further in your answer, so once you factor the difference of cubes, you are good. All right, now let's look at a sum of 2 cubes. These ones are kind of the same approach. So we have 2 terms. 8, I know, is not a perfect square, so right away I'm not doing squares. So I'm going to check, are these perfect cubes? So let's look. Let's try the cube root of x cubed, which is x, because we have 3 x's that are being multiplied, so we have that group of 3. Then the cube root of 8. And we did that one already. The cube root of 8 is 2. If you don't know that, you can do your factor tree to get groups of 3 or your calculator. And notice for both of these, the GCF was 1. So we didn't have a greatest common factor to factor out yet. You should always check for that. Now, because I know these are perfect cubes and we're going to do the sum of cubes. So the sum of cubes starts with our a plus our b. And then we are still going to have a squared and b squared at the beginning and the end of our second one. But we need a subtraction sign in here, so we're going to subtract a times b. So again, when you factor it, you should only have one subtraction sign in your entire thing once it's factored. Now we can set it up. Our a value is x and b is 2. So we're going to start with x plus 2. Then when we take our a squared, we're just squaring an x, which is x squared. Oops, my page moves. There we go. Then we need to figure out what a times b is. So x times 2 is just a 2x. And then lastly, we need our b value squared. So 2 squared is going to be 4. Once we are done with that, that is our factored answer. And again, we're not going to be able to factor that second set of parentheses there. So even though it has 3 terms and usually we are factoring further, you are not going to be able to for your sum and difference of cubes. All right, so that's an example of one of each. The next video is going to go over the last 2 examples for sum and difference of cubes. So if you need more examples or you want some guidance after you try these, you can check the video to see if your answers are correct.